Hi, this is Avsandrajit Promi. Here I have come up with my thesis topic, which is the production of polylactic acid from cellulose, and it can be an effective solution for the production of bioplastic. Now, we all know that traditional plastic contains carbon, hydrogen, chloride, nitrogen, which can be derived from the fossil fuels, and it emits lots of greenhouse gas at each stage of its life cycle and responsible for global warming. It also takes extremely long year, even thousands of years, to decompose completely, and even after decomposition, it emits lots of toxic chemicals to the soil. So to overcome these negative impacts, scientists are trying to invent biodegradable plastic, which is known as the bioplastic. It can be protein based, starch based, bio-driven, polyethylene, etc. Among all these type of bioplastic, polylactic acid has gained more attention because of its less carbon footprint, better physical mechanical property, and wider application. Polylactic acid is a biodegradable, bio-based polyester, and which can be produced using a wide range of raw materials, and depending on these uses of raw materials, it can be divided into first generation polylactic acid and second generation PLA. In this case, I have used the pure crystalline cellulose, which can be derived from different types of lignocellulosic materials, and as a raw material, and the production of polylactic acid has been done in this case. And to objective of this thesis is to investigate the production process and to analyze the property of this lactic, polylactic, and glucose. So the total methodology has been converted into three parts, which is in the first part, the pure crystalline cellulose has to be hydrolyzed into glucose monomer, and this in this case we have get this kind of glucose uh, monomer. And after this, we have to convert this glucose into lactic acid using at high temperature using solid catalyst, and I have used Knoffel furnace in this case for the heating process, and we have get this type of lactic acid. Next, this lactic acid is converted or polymerized to produce the polylactic acid using heating up to 24 hours. Here the cellulose and lactic acid FTR graph has been shown and compared it with their reference wavelength, and which this wavelength is assigned for different bonds of this lactic acid and glucose. And the yield for the glucose solution, glucose from this cellulose was 83.6% when the temperature was 245 degrees Celsius, and heating time was 17 minutes at 1% VNV concentration of sulfuric acid. The pH of this glucose, lactic acid, and polylactic acid were acidic condition, and lactic acid showed a more acidic nature as it is more acidic in nature. The acidity test of this lactic acid was done using a titration with sodium hydroxide, where the dark pink color was at the initial stage, and after the titration it looks faint pink color. So now in the conclusion, I could conclude this as a very effective and promising sector for the production of bioplastic, and we can use this bioplastic in every sphere of our life, and we even some plastic products that we are using right now can be converted into this biodegradable PLA. And here we can use different types of lignocellulosic raw materials for the production of this polylactic acid from using the core cellulose as the raw material. So I conclude here. Thank you everybody.